networking, IAM, and VPC endpoints, private GenAI on AWS. This is the day where AWS stops asking whether you can build GenAI and starts asking whether you can build it without accidentally exposing everything to the internet. This is about privacy, least privilege, and control. Imagine this. A large bank wants to use Amazon Bedrock for internal workflows. They say three things very clearly: no traffic over the public internet, no broad IAM permissions, everything must be auditable. Those three requirements immediately force your architecture in a very specific direction. You must get IAM, VPC endpoints, and encryption right. This is the story AWS is testing. Let's start with IAM. Because IAM is AWS's favorite blunt instrument, IAM answers one simple question: who is allowed to do what? And AWS expects you to answer that question precisely. There are two types of IAM policies you must understand. Identity-based policies attached to users or roles. They define what this identity can do. Resource-based policies attached to resources like S3 buckets or KMS keys. They define who can access this resource. Both matter in GenAI systems. The most important rule is least privilege. Only allow the actions needed, only on the resources required. And remember this AWS law: an explicit deny always beats an allow. In GenAI architectures, AWS expects you to separate IAM roles, not one giant role, separate responsibilities. First is the application runtime role. This is the role used by Lambda, ECS, or EC2. It usually needs permission to invoke Bedrock models, retrieve from a knowledge base if you're using one, read from S3 for prompts or documents, and possibly access OpenSearch if you built custom RAG. This role should never have wildcard permissions. Second is the data ingestion or indexing role. This role is used by pipelines that read documents from S3, generate embeddings, and write to a vector store. It does not need permission to invoke models for user traffic. Keep it separate. Third is the human or admin role. This is for engineers, creating knowledge bases, updating guardrails, changing configurations. This role should never be used by the application at runtime. AWS loves this separation. Now let's talk about common IAM exam traps. If you see Bedrock on, that's wrong. If you see one role doing runtime, ingestion, and admin work, that's wrong. If you see encrypted S3 or secrets without KMS permissions, also wrong. Most people forget KMS. AWS does not. A bonus topic the exam loves is IAM conditions. Conditions let you say when and from where an action is allowed. You might restrict access based on the source VPC endpoint, resource tags, or encryption requirements. For example, allowing S3 access only when requests come from a specific VPC endpoint. This is very exam-friendly. Now let's move to networking, specifically VPC endpoints. This is how you keep traffic private. There are two types of VPC endpoints you must know. Gateway endpoints are used for S3 and DynamoDB. They work at the route table level. They are simple, cheap, and very common. Interface endpoints use AWS Private Link. They create elastic network interfaces in your subnets. Most AWS service APIs, including GenAI adjacent services, use interface endpoints. DNS resolves the service name to a private IP. No internet involved. Why does this matter for GenAI? Because if you want private calls from Lambda or ECS, no NAT gateway, controlled outbound traffic, and compliance with no public internet rules, you use VPC endpoints. This is not optional in regulated environments. Here's the exam pattern to recognize. If the question says, must not traverse the public internet, private connectivity, no NAT or compliance requirements, the correct answer includes VPC endpoints. Always. Now visualize the core private GenAI architecture AWS expects. Your application runs in private subnets. No public IPs. You use an S3 gateway endpoint for documents, prompts, and logs. You use interface endpoints for AWS service APIs. Your vector store lives inside the VPC or is accessed privately. Outbound internet is blocked or tightly controlled. This is what good looks like. Security groups matter here. They are stateful and used everywhere. They allow your app to talk to endpoint network interfaces, OpenSearch, and internal APIs. Network ACLs exist, but are rarely the primary answer unless the question specifically asks about subnet-wide controls. Keep it simple. Routing is also straightforward. Private subnets route to interface endpoints through ENIs. S3 traffic goes through the gateway endpoint. NAT gateways are used only if absolutely required, and often avoided in regulated setups. Now let's map common exam scenarios. If documents are in S3 and ingestion must be private, Use an S3 gateway endpoint and an IAM role with S3 getObject and KMS decrypt. If an app must call an AWS service privately, use an interface endpoint and security group rules. If access to S3 must be allowed only through an endpoint, use an S3 bucket policy with the AWS source VPC condition. If everything must be encrypted, use KMS and remember to grant kencrypt, KMS decrypt permissions. This is where many people fail. Before we finish, here's the exam grade checklist. Separate IAM roles for runtime, ingestion, and admin. Use least privilege actions and scoped resources. Use S3 gateway endpoints for private S3 access. Use interface endpoints for private service API calls. Restrict access using a source VPC where appropriate. Never forget KMS permissions. Log everything using CloudWatch and X-Ray. And here is the one sentence to lock it all in. IAM decides who may do what. VPC endpoints decide how traffic gets there privately. If you remember that, this entire topic becomes easy.